Okay, now substitute this xn of x in equation 1. ನಾನು ನೋಟ್ಸಲ್ಲಿ ಇಲ್ಲಿ equation 2 ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ, ಅದು equation 1 ಆಗಬೇಕು, ಅದನ್ನು ಸರಿ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, equation 1, then equation 1 will becomes u of x comma t equals summation n equals 0 to infinity sin n pi over l into x into tn of t. We call this as equation number 4. Okay, next we move on to the source term. Okay, so as in your previous chapter we already know about how to solve the source term or how to expand the source term. Okay, here also we expand the source term as in your previous chapter. Okay, now here the source term is f of x comma t. Now we solve this source term, or sorry, now we expand this source term as f of x comma t equals summation n equals 0 to infinity fn of t into sin n pi over l into x. We call this as equation number 5. Now, so using the orthogonal property or apply the orthogonal property to equation 5. So then we have fn of t equals 2 over l into integration from 0 to l f of x comma t into sin n pi over l into x. We call this as equation number 6. Okay, now substitute equation 4 and equation 5 in the given equation. Okay, so then the partial differential equation as, look here, then we get the differential equation as summation n equals 0 to infinity, so tn double dash of t into sin n pi over l into x, which is equals to minus c square n square pi square over l square into summation n equals 0 to infinity sin n pi l over l into x into tn of t plus summation n equals 0 to infinity fn of t into sin n pi over l into x. This is the source function. Okay, now so again we rearranging this one, so we get summation n equals 0 to infinity tn double dash of t plus c square n square pi square over l square into tn of t minus fn of t into sin n pi over l into x, which is equals to 0. Okay, so now applying the orthogonal property to this equation, we get tn double dash of t plus c square n square pi square over l square into tn of t, which is equals to fn of t. Okay, we get the ordinary differential equation. Okay, homogeneous differential equation. Now here we find the solution of this equation. So here we have a non-homogeneous equation. So for that one, the solution is in the form complementary solution plus particular integral. First we find the complementary solution, so for a homogeneous equation. So therefore this complementary solution of the above homogeneous equation as, look here, tn of t equals c1 into cos cn pi over l into t plus c2 into sin of cn pi over l into t plus particular integral. Next we find the particular integral for the non-homogeneous term. So for that one, we consider pi 1 and pi 2 value, that as, so this was pi 1 and this is pi 2. So therefore pi 1 equals cos cn pi over l into t and pi 2 equals sin cn pi over l into t. Okay, so in the next we find the Wronskian value by using these pi 1 and pi 2. Okay, the Wronskian value will becomes cn pi over l. So solve this one, we get the Wronskian as cn pi over l. So next we find u1 and u2 value. First we find the u1 equals minus integration from 0 to t b of t into pi 2 of t in over Wronskian of t into dt, which is equals to minus integration from 0 to t. So b of t in the sin cn pi over l into t into pi 2 of t means fn of t over Wronskian value cn pi over l into dt. Okay, again this can also be represented as, we take the constant into out of the integration, so we get minus over cn pi into integration from 0 to t sin cn pi over l into t into fn of t into dt. This is the u1 value. Okay, so next similarly we find the u2 value, so that is u2 equals integration from 0 to t b of t into pi 2 of t over Wronskian of t into dt. So which is equals to we get l over cn pi into integration from 0 to t cos of cn pi over l into t into fn of t into dt. This is u2 value. So then the particular integral will becomes u1 into pi 1 plus u2 into pi 2. Substitute all u1 u2 and pi 1 pi 2. Finally we get the particular integral as, look here, cos of u1 means, so this 1, and pi 1 means, so here, so this is pi 1. Pi 1 is cos cn pi over L into t. Similarly, pi 2 is sin cn pi over L into t. Okay. Here also, look here. So first we write the pi 1 value, that is cos cn pi over L. This is cos. Okay. So ಅಲ್ಲಿ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಬರ್ಕೊಳ್ಳಿ, ಇದು cos cn pi over L into t into this is pi 1. Okay. Plus u2 into pi 2. Okay, u2 ಏನಿದೆ, so pi 2, this is sin cn pi over L into t, this is pi 2, and this is u2. Okay, again, so this is the particular integral. Then we write the total solution, Tn of t is equals to complementary solution plus particular integral. Okay, now substitute this Tn of t in the solution in u of x comma t. Then u of x comma t will becomes, observe here, x comma t is equal to summation n equals 0 to infinity sin n pi over L into, this is x not t. Okay, so into x into, okay, so Tn of t, so this is Tn of t, complementary solution minus, so this one means this is the particular integral. ಇಲ್ಲಿ ಸ್ಪೇಸ್ ಇಲ್ಲ ಅಂತ ನಾನು ಈ ಒಂದು ವ್ಯಾಲ್ಯೂನ ಈ ರೀತಿ ಬರೆದಿದ್ದೀನಿ. ಓಕೆ, ಇಲ್ಲಿ ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಸೊ ಇಲ್ಲಿ ಏನಿದೆ ಈ ವ್ಯಾಲ್ಯೂನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ದ ಸೊಲ್ಯೂಷನ್. ವಿ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಈಕ್ವೇಷನ್ ಸ್ಟಾರ್. ಇಲ್ಲಿ ನೋಡಿ, ಸೊ ಇಲ್ಲಿ ನಾನು ಫಸ್ಟ್ ಕಾಂಪ್ಲಿಮೆಂಟರಿ ಸೊಲ್ಯೂಷನ್ ಅನ್ನ ಬರೆಯುವಾಗ c1 ಇಂಟು ಕಾಸ್ ದಿಸ್ 1 ಪ್ಲಸ್ c2 ಇಂಟು ಬರೆದಿದ್ದೆ. ಆದರೆ ಈ ಕೋಎಫಿಷಿಯಂಟ್ ನಾನು an and bn ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಓಕೆ, ಸೊ ವಿ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಈಕ್ವೇಷನ್ ಸ್ಟಾರ್. ನೆಕ್ಸ್ಟ್ ವಿ ಯೂಸ್ ದ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್. ಸೊ ದ ಫಸ್ಟ್ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ಆಸ್, so u of x comma 0 is equals to f of x. So first we consider that initial condition. We apply this initial condition in equation star. Then that equation will becomes f of x equals summation n equals 0 to infinity sin n pi over L into x into an. So ಅಲ್ಲಿ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ ಅಲ್ಲಿ t ವ್ಯಾಲ್ಯೂ 0 ಇದೆ, ಅದನ್ನ ನೀವು ಈಕ್ವೇಷನ್ ಸ್ಟಾರ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಸೊ ಈ ಈಕ್ವೇಷನ್ ಸಿಗುತ್ತೆ. ಓಕೆ, ನಾವು ಅಪ್ಲೈ ದ ಆರ್ಥೋಗೋನಲ್ ಪ್ರಾಪರ್ಟಿ ಟು ದಿಸ್ ಈಕ್ವೇಷನ್. We get an is equals to 2 over L into integration from 0 to L f of x into sin n pi over L into x into dx. We call this as equation number 7. Similarly, now we are using the another initial condition, that is ut of x comma 0 is equals to g of x. Okay, so here we they gave the initial condition as derivative of u with respect to t. Okay, so first we differentiate the equation star. After that we substitute this initial condition, or we apply this initial condition. So then that equation will becomes g of x equals summation n equals 0 to infinity sin n pi over L into x into bn. Now apply the orthogonal property to this equation. We get bn equals 2 over L into integration from 0 to L g of x into sin n pi over L into x into dx. Okay, now call this as equation number 8. Now substitute equation 7 and 8 in equation star, then we get the required solution. Okay, look here, hence equation star is the required solution with an and bn in defined in equation 8, equation 7 and equation 8 respectively. ಓಕೆ, ಸೊ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಕೂಡ ನೀವು ಸೊಲ್ಯೂಷನ್ ಬರೀಬಹುದು, ಅಥವಾ ಈ ರೀತಿ ಹೇಳ್ಬೋದು. ಈಕ್ವೇಷನ್ ಸ್ಟಾರ್ ಇಸ್ ದ ರಿಕ್ವೈರ್ಡ್ ಸೊಲ್ಯೂಷನ್ ವಿತ್ ಎನ್ ಅಂಡ್ ಬಿ ಎನ್ ಡಿಫೈನ್ಡ್ ಇನ್ ಈಕ್ವೇಷನ್ 7 and 8 ರೆಸ್ಪೆಕ್ಟಿವ್ಲಿ. ಓಕೆ, ಸೊ ಹೆನ್ಸ್ ವಿ ಫೈಂಡ್ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ದ ಗಿವನ್ ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್. ಓಕೆ, ಸೊ ಸಿಮಿಲರ್ಲಿ, ಸೊ ನಿಮಗೆ ಹೋಮ್ ವರ್ಕ್ ಕೊಡ್ತಿದ್ದೀನಿ, ಇದೇ ರೀತಿ ನೀವು ನೆಕ್ಸ್ಟ್ ಮನೇಲಿ ಕುತ್ಕೊಂಡು ಮಾಡಬೇಕು. ಏನಿದೆ ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್, ಆಕ್ಚುಲಿ ನಾನು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ ಅನ್ಸುತ್ತೆ. So ನೋಡಿ, find the solution of the equation. This equation here, the source term is f of x comma t. When subjected to the boundary condition u of 0 comma t equals u of L comma t equals 0, with an initial condition u of x comma 0 is equals to sin pi x and ut of x comma 0 is equals to 0. ಓಕೆ, ಪ್ರೀವಿಯಸ್ ಪ್ಯಾರಾಬೋಲಿಕ್ ಈಕ್ವೇಷನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಮಾಡಿಸಿದ್ದೀನಿ, ಇದನ್ನ ನೋಟ್ಸ್ ಕೂಡ ಕೊಟ್ಟಿದ್ದೀನಿ. ನೀವೇ ಇದನ್ನ ಮನೇಲಿ ಕುತ್ಕೊಂಡು ಟ್ರೈ ಮಾಡಿ, ನೋಟ್ಸ್ನ ನೋಡ್ಕೋಬಾರ್ದು, ಹಾಗೆ ಮನೇಲಿ ಕುತ್ಕೊಂಡು ಟ್ರೈ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ. ಓಕೆನಾ, ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು ಈಸಿಯಾಗಿ. ಓಕೆ, ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಮೆಥಡ್, ಹೌ ಟು ಸಾಲ್ವ್ ದ wave equation by Laplace transformation method. Okay, thank you.